The growth potential in this market is less about public networks and consumers, and it's more turning into industrial and private networks. But why is that? Well, when we look at what private industries and enterprises are doing, they're connecting most everything around them. I mean, look at our facility here at MultiTech. Look at all of the stuff that we've amassed in this building in the time that we've been here, right? I mean, almost all of the assets of MultiTech are inside this building. And that includes all our factory line production equipment, the heating, ventilation, the equipment that we bring into the premises in order to facilitate more efficiencies and new equipment purchases. All of this stuff is being connected, but it tends to be, for us as an enterprise, more inside this building. Now, clearly there are applications like container tracking where you track things all over the world. So those use cases are very definitely in the market. But increasingly for an enterprise, it becomes much more inside a building or a campus or a facility. And when you start clustering lots of assets inside a building or a facility, then you've got to start asking yourself the question, well, maybe if I built the network and it could only cover my building, I could save a lot of money here. Instead of paying a commercial operator every month for every single asset I bring into the building that's connected, I can put it on my own network. All right, I have a higher upfront cost to do that, but once I've paid that higher upfront cost, I don't have to pay anything to connect to my network. It's really no different than buying a Wi-Fi access point in your house. You're out of pocket for $150, but then you connect maybe 15 things in your house, and when your friends and family come over, they connect to it as well. And so you're able to dramatically reduce your costs, and this hasn't been lost on enterprise. Industrial enterprises all over the world are starting to realize now that they can dramatically reduce that ongoing monthly contribution that they have to spend on connectivity. But they also get other benefits out of it as well. They get greater privacy of their data. Their data, for example, stays inside the building. It never leaves the corporate network. And with public networks, we often have to, hang our head out of the window or hang up and dial back in again when we get around the corner. Well, in our own private network, of course, we dimension that network to be perfect for our applications, for the things that we're trying to connect. And because we put it inside our facility or our campus, we're never given less service than the next guy. We always give ourselves primary service on that network. So we have high availability, we have the great local coverage that we need to connect all of our applications in a way that's very secure and private, and it costs less. And the break even on these networks is perhaps only a couple of years on assets that might live for over 10 years. The types of examples of different enterprises that are now embracing this is private LTE. This is an area where we've been quite prolific in trying to get that moving with more industrial type companies in warehousing, factories, and mines and wherever. But there's other groups as well that are embracing this. So there's the concept of a neutral host. A neutral host could be like the Viking Stadium downtown. They kit the entire stadium out in a private LTE network. When you guys turn up to watch the games or a rock concert or whatever, you get really great, cool quality. You get to upload all your favorite videos that are coming off of your 12 megapixel camera. And you're able to put that onto social media and very quickly see, all of your friends and families, liking all the boasting that you're doing. And so there's good revenue in that for those neutral host owners like the Viking Stadium. And with that model, they're then able to connect up all the other things inside that building without any OpEx. And then there's fixed wireless access. These are the guys that are offering you TV or internet service, but instead of wiring it to your house and having to dig up the streets to put in fiber, they can come into a market like Mounds View. They can perhaps put a base station on those two massive, great big antennas that are down the road, and they can cover this whole facility. And they can provide high-speed internet to MultiTech, to the guys across the road, to the Mermaid, to anybody who signs up for that. And their investment to get into that market is pretty low. So to give you an idea of just how big this whole private network thing could be, companies like Harbour Research and big infrastructure providers like Nokia have done quite a lot of research into this. And Nokia, for example, estimates that there are well over 14 million different sites around the world that could be a private LTE deployment, much like, say, MultiTech here. And that could be sports stadiums and racetracks. It can be mines, warehousing, transportation, dockyards. I mean, the list goes on and on and on. Nokia even perceives that they will sell twice as much infrastructure into those networks than all of the infrastructure that they've sold into those public networks. So the size of this market starts to get really, really, really big, with manufacturing being right up there at the top. And to put that into context, let's look at the kind of things that we understand, the things that we buy and do, right? So if we look at the mobile phone market, as I said, there was 1.5 billion devices that shipped last year, and they're all on a service plan pretty much, right? And if you add all of that up, that was broad stroke in the whole thing, about $250 billion of revenue globally, which is, a nice chunk of change. If we look at the TV industry, again, more of this is probably brand new 4K OLED TV sales, but there is the attachment rate to Hulu's and HBO Now's and cable TV and other types of services. And that's over 140 billion. Even the light bulb business, again, probably more light bulbs than service, but in a lot of commercial and industrial situations, that lighting has a service component to it from a management company. And even that's a $15 billion business. But if we look at buildings, and we're no exception in this building, I constantly lose calls or have people tell me that they can't hear what I'm saying when I'm using my mobile phone. But 40% of all buildings in America, and perhaps even more of a percentage in other parts of the world, have crappy coverage. And when you go to look at a building, to buy it, to lease it, to rent it, the first thing anybody does when they go into a building is they walk in, does it look nice, and they immediately start looking at their phone to see how many bars of service that they've got, right? And so being able to provide better cellular coverage in large commercial buildings enables these REITs and landlords to be able to get considerably more rental for their facility. It becomes a more desirable location. And like a restaurant, as more cool people start coming into the building, it gets more cool people to join them and follow at premium rents. And so just to play that out, some smart people out there, they worked out exactly how many square foot of office and building space that there is just in the USA. And they sort of broad stroked it as 85 billion square foot. Of course, we know that 40% has pretty crappy coverage. And if you apply $2 per square foot per month to that, and maybe that's a little high, maybe it's only $1, right? But if you apply that kind of number, you're out at 400 or perhaps even over $800 billion of revenue. Now, granted, that's the very top of the pipeline. It's not perhaps every installation that gets installed, but that total addressable market at just $1 a square foot per month to provide base stations and coverage is considerably bigger than that handset business. And this is really the quandary that the industry is in now. I've been to Mobile World Congress this year, and I've been to Hannover Messe a couple of weeks ago in Germany. And these are big shows. They're both well over 100,000 people attend these shows. Massive stands by all the biggest companies in our industry. Mobile World Congress, a little bit more cellular. Hannover Messe, a lot more industrial. But what I saw between both of those is pent-up demand to deploy private networks into industrial and enterprise facilities. But at the same time, the traditional operators out there, the AT&Ts and Verizons and Vodafones of this world, not really understanding how they can play in that market and how that market may turn on them very quickly in a way in which the business model of this industry changes. So if we look at quite what you get from your private LTE network, you get one network that rules them all, right? If you look at utilities and oil and gas, for example, they use lots of different types of networks. They use unlicensed band technologies to connect some devices out in the field, transformers maybe. They use proprietary RF from specific companies who have designed a particular transmission technology that perfectly meets the latency and the bit rate and the mission critical nature of a particular type of asset that they're trying to connect. Often it's mesh networks, and often as not, it's a type of technology perhaps deployed in a very specific licensed band frequency with very specific rulings on it. And what ends up happening is that they might have 20 different applications in their network, everything from voice and sensors, mission critical equipment, laptops and what have you, but they end up having 20 different networks to manage those assets. And wouldn't it be better if they had one network that was running 20 different applications? And that's the real benefit that private LTE and private 5G brings to these facilities. So for example, in an oil field, they can use voice terminals that do one-to-one communication or one-to-many, essentially like the old Nextel push-to-talk. You can do mission-critical push-to-talk over cellular. You get the broad enhanced mobile broadband connectivity that 4G and 5G now coming into the market can provide you. But you can also connect up all the sensors as well. So you get this broad amount of connectivity that can connect all of the assets. But there's a catch, right? And what is that catch? The catch is that it's wireless, right? We have to use wireless spectrum. And wireless spectrum is at a premium. I showed you this image last time. I liken it to, the ocean over here where the coverage bit sits, and then the mountains up over there where the capacity sits. And of course, close to the beach, it's full of everybody's beach towels. They're all right next to each other like sardines. But as we go up into the mountains, it all spreads out, right? And so in a world where it's very very dense down in that sub-2 gig area, where do we move to? And how do we pick off all these little bits of spectrum and use them in meaningful ways? So one of the ways in which the industry is doing this now is with mid-band spectrum. So mid-band spectrum typically sits between this sort of 4.5 gigahertz. Up to a few years ago, this wasn't considered very desirable real estate. You were definitely not getting the waves lapping at your feet. I mean, you were a little bit further up. The ability to deploy macro networks wasn't very easy because the range wasn't good. Being able to connect buildings and all the assets that might be into a basement wasn't too easy going through all the concrete at this sort of 3.5 gig range. But with improvements in signal processing, massive MIMO, beamforming, and other technologies, this is now becoming very viable real estate. And a number of the bands that we see here or in fact going back a step, I guess, a number of different organizations are using this spectrum in different parts of the world, right? So nothing to do with cellular, but maybe radar systems, maritime, satellites, TV, this kind of type stuff. But increasingly, cellular is being put into these bands. The bands that we see a lot of capacity on, or a lot of interest on, I should say, is band 42 and band 43. A lot of that's in Europe and parts of the Middle East and Asia. And as you can see, 42 starts at 3.4 gig and it goes up to 3.6. And then band 43 goes from 3.6 to 3.8. In this country, there's band 48, which is often referred to as CBRS, Citizen Broadband Radio System. And as you'll see in the slide in a moment, that's between 3.55 and 3.7 gigahertz. And so whenever you can get 100 or maybe even 200 gigahertz, you're rich. I mean, this is spectrum, and there's a lot you can do with that amount of spectrum. And it's sat there in that mid-band area. In fact, this mid-band area is getting so hot now that, that 5G new radio is now banded for N77 and N78 right across this real estate of spectrum, all the way from 3.3 all the way up to 4.2 in the case of N77. And when we start looking at different countries around the world, so we start looking at France, and their regulator is called ARCEP, and they've done a proposal here in that 3.4 to 3.6 range in band 42 for industrial usage. So this wouldn't be for the public to use on a Orange network or a Bouygues telecom network. This would be an amount of frequency that would be allocated to Citroën and Renault and Airbus and every other industrial big and small company in France. Germany did the same thing. The Netzagentur for Germany, they've now allocated the upper part of band 43 for, again, industrial networks. Volkswagen is going to deploy industrial networks into 100 or more of its facilities, and a lot of those in Germany will use that frequency band. But here, and of course over in the UK, Ofcom, they're looking at doing everything from 3.8 to 4.2 gigahertz. That's 400 meg of spectrum. That's like tripping over Fort Knox in terms of spectrum. There's so much you can do with 400 megahertz. And so, in a sense, this is what's happening in the USA with band 48. Band 48 is an experiment in how to share spectrum. So typically, to get access to spectrum, we had 3 different ways in which we could do that. We could buy the spectrum, or we could sublease it off of somebody. Remember, there's only so much spectrum, and it's heavily used, especially as you go lower down in the frequency bands. But there are companies that broker spectrum. They buy it and they cut it up into parcels, like this bit for Minnesota, this bit for New York, and they'll parcel it up and make more than the sum of what they purchased it for. The operators like AT&T are beginning to realize that they can map their cellular network, so every base station is using a different frequency, and maybe every 3 or 5 base stations in a line, they start reusing the same frequencies again, and they map that across the whole country. Well, hypothetically, MultiTech could lease that spectrum off of AT&T, and here in this facility, we'd be using the same spectrum that AT&T uses, but we would have a little bit of a different network color code so that anybody's AT&T device that came near us or into our building wouldn't connect to our network. Our network would all live in this building, it would be in IT, we'd put up some small cells in the building, but we'd physically be using that spectrum that AT&T uses in other parts of the country. Of course, that comes at a cost, and it's not going to be cheap. Unlicensed band, the kind of things that we do with Wi-Fi, is real easy, right? We wheel in an access point, we turn it on, we don't even bother to think about how it might interfere with the guy next door, and we just throw it up. I mean, even better, take a phone, put it in hotspot mode. Did you ever bother to look at what's around you? You just randomly pick a channel. And what shared does is it takes the best of both of this and it brings it together. You get the high availability of licensed spectrum that you own, that you have exclusivity to, that you're the only one who gets to use it. And you get this ease of operation of I can just put up stuff and not have to buy expensive licenses and highly bureaucratic systems. And I can bring up a shared spectrum service. And in this country, that's called CBRS. And as you saw in the last slide, Germany and France are now adopting what is a first-in-the-world experiment by the FCC to utilize this shared spectrum to get the benefits of ease of use with exclusivity and high availability. So let's have a little look at CBRS and do a bit of a deep dive on that. So with CBRS, there are three types of users. At the very top of the tree is the incumbents. And so they're guys like the Department of Defense, satellites, this kind of stuff. Below them is the PAL users. These are the priority access licenses. These guys have actually paid for a license, or at least they will do next year when those licenses are up for auction. And that gives them some priority in the system. And then there's the general access, authorized access guys who then represent the bottom of that pyramid. The bottom of that pyramid is wider because that's the full 150 megahertz spectrum that is FCC CBRS. The PAL is smaller, not only because there will be less people who buy a license or less enterprises, but also the enterprises only get access to 70 meg of that 150 meg spectrum. So they can't just gobble it all up and eat it for themselves. And then at the very top, we have the incumbents like the DoD. They get first dibs on everything, but they're not even using all of the 150. Now, the FCC has been doing trial licenses for a while now, for a year or two, and there have been a number of different trials done. OnGo, for example, did a very highly publicized trial at Dallas Love Field Airport, where they completely lit up the whole airport with a private LTE network using the CBRS band frequency, and they started to connect users, people coming in with their phones so that they get a better call quality and higher data rates, but also the infrastructure around the airport, like the tugs and the plane delivery systems and what have you. A lot of neutral hosts have started putting in networks as well. So sports stadiums around the country have started trialing this out to sort of see how it can work for them. They've already been using Wi-Fi, so it's a natural evolution to see how much more they can add on to the network. And perhaps if they can make a revenue stream out of offloading all of that traffic from your phones to AT&T, Verizon, T-Mobile, and all of the other carriers, that they can connect your device to the service that you pay for. You don't see it, of course it's transparent for you. And then the fixed wireless access guys has also represented a large amount of the trials. So that's the rural, underserved markets in the country who typically aren't getting much internet connectivity, perhaps a meg on twisted pairs that have to travel a long way, and so the data rate isn't very high. With this technology, they can put up stuff on antennas and they can beamform a signal directly to commercial or residential property. So let's have a little look at those incumbents, right? So I referred to the Department of Defense. It's actually the Navy who's really using this. And so as you can imagine, most of that traffic is around those coastal areas of the country. The chances, of course, of seeing much of the Navy in the middle of the country is a bit slim. So already you've got a service that's being used by the Navy, but really most everybody on the inside of the country, any more than about 50 miles in, they're not affected by this at all, with the odd exception of some missile sites like White Plains or wherever. So, for most people and most enterprises, the Navy shouldn't be an issue. And then there's these grandfathered licensees. These guys are WISPs, wireless internet service providers. And they're the guys that are serving these underserved markets in the country. So typically, you tend to see that more in the middle of the country. And they're offering high-speed internet connectivity. In fact, we have some guys from Cambian in at the moment having a meeting upstairs. And Cambian owns much of the technology that these WISPs are using. It's a classic mid-band 3.5 gig technology to deliver a somewhat broadband connectivity. But these guys have all been given their eviction notices, or at least they got the note that they're being evicted. It was meant to be the end of 2020. They're cut. They've got to turn everything off, get out of town. Of course, they're negotiating with the FCC a bit of an extension. Maybe it's a quarter or so. But pretty much, end of 2020, they're cut, they're kicked out. Most of them, I'm guessing, will transition to a CBRS service so that they can continue to offer fixed wireless access in the markets where they've built up their customers. But it won't be competing technologies. And that's important because with CBRS, we can share the spectrum. So how's that done? Well, we've got all of the devices over here, devices by MultiTech, handsets, and other mini PCI Express cards that have been put out into the market. They obviously connect to a base station. The base station is called a CBSD, and the CBSD comes in two flavors, a Category A and a Category B. Category A is for inside a building, like here, like the wireless access points or the conduit that you see up there, attached to the ceiling or wherever. The output power of a CAD A is quite low. It's no different than a conduit. It's about 23 or so dB. So the ability to be able to interfere with that product is quite a bit less, particularly because it's generally inside a building, which gives you about a 20 dB buffer to get out of the building anyway. Of course, the outdoor ones are mounted high up on transmission masks. They're whacking out at the full cellular output power of 47 dB. So that's the maximum amount of interference can be caused by those. And this is the game changer for CBRS. This is the magic of how you create all the good of unlicensed with all of the good of licensed. It's through this complex sharing technology, which is referred to as a SAS. There are more than one SAS provider out there. The SAS is connected to an FCC database that has all of the different deployments that are out in the world and is able to provide the SAS with more information about all those small cells and the locations which they're intending to be put into. It's also connected to an ESC network, a sensing network, and you see it on the other side there. Unsurprisingly, it's on the coastline, right? It's looking for those Navy ships, or at least the radar coming off of them. And as soon as it senses that it's seeing that radar, that signature image coming off of those flight operation radar systems on these Navy ships, it then feeds that into the SAS, and the SAS has no longer than 5 minutes to move every one of those CBRS outdoor and indoor base stations to a different frequency so that they are not interfering with the Navy. The SAS is also making sure that all the different base stations from different companies and different providers are not interfering with each other. So that's kind of how the sharing ends up working out. Now, I know what you're saying. What about the most densely populated parts of the country, which are the bits around the edges, right? New York, Los Angeles, Seattle, San Diego. What about those guys? Well, it turns out that the Navy isn't really using all of the spectrum anyway. Out of a total of 17 ships that are using this radar system that uses 3.5 gig, Typically, 35% of these ships are forward deployed. They're nowhere near the US. They're out doing war games off the coast of South Korea or the Philippines or somewhere. They're not even close to us. And then about 30% of them are in shipyard repairs. I mean, you know, you think it's bad owning an old house? Try owning some of these boats. These boats need permanent repair all the time. So that leaves about 6 ships that are actually out there interfering with us at any time. So let's allocate, I don't know, 2 per coastline if we're doing east and west and the Gulf, or maybe we just add the Gulf into the east and call it 2 coasts. But there's like 2 or 3 ships out there at any given time. And most of them are only running the radar when they're doing flight ops, which is less than 8 hours a day. And when they're doing that, they're typically, you know, somewhat off the coastline. They're like maybe 50 miles out. I often go down to San Diego and you see all the aircrafts flying out from Mira Mesa, and they just fly right over your head, and they just go off into the Pacific. You don't even see where they go. Beyond the horizon is an aircraft carrier, and they're all doing their war games and they're practicing. So if you can't see that ship, it's a long way away. It's not going to create too much interference, especially inside a facility a mile or 2 back from the coastline. And even if they are right up against the beach and blasting this out, they're only using 20 meg of the 150. So if you buy a PAL license, I think it's fair to say you're always going to get what you bought. And even if you're a GAA license holder, you might be constricted down from perhaps the 40 meg of bandwidth that you wanted to have down to 20 if a radar system comes on. But you're still getting a high broadband connectivity, and you're not paying a single license fee for that. So OnGo is the brand name of CBRS. And through all of that SAS and ESC sensing network and a little bit of complexity that the CBRS Alliance with the brand name OnGo has put into these small cell base stations, we've unlocked in the USA 150 meg of prime real estate that was fallow. And this is a world first. And as I showed you in the slide earlier on, France, Germany, the UK, other Asian countries, they're all following suit to see how this experiment works out in the US and copying it for their own industrial growth. I mean, I'm not sure if some of you have been following the millimeter wave auctions that have been going on for 5G, where they're auctioning frequency up at 24 and 27 gigahertz. Do you know how much money the government got for auctioning that frequency off? Did anybody see any of those press releases? Well, it's sort of ongoing because they're still sort of selling bits of it, but it's over $2 billion. I mean, that's a lot of money, right? I could definitely have a nice life on that. But this is nothing. It's nothing. It's a drop in the ocean compared to rising GDP per capita by $1,000. If all of us in this country raised GDP per capita by $1,000, this makes $2 billion look like lost change down the sofa. And so this is what government's doing. It's empowering commercial operators to offer nationwide services for us to connect, to grow economic growth and global competitiveness. But it's now allocating frequency for enterprises and industry to grow productivity and global competitiveness in a way in which dwarfs anything that public networks have done. So let's have a little look at that ecosystem. So this is a number of companies that a few of us have been talking to, right? So just to get an idea of what you're looking at, we're over here in the modem router piece. We're not the only guys, and I'm sure many more will come as the rest of the year and next year plays out. And our vendor chain is coming from Qualcomms and Telets and Sierras and Sequans and GCTs and what have you. And that's how we're building the devices. But the devices need to connect to the network. And you saw that there's a SAS. So the first 3 SAS providers that got approved was Google, CommScope, and Federated Wireless. There's another 4 coming through. There's another 7 behind them. So there's going to be a lot of these SAS providers. And of course, you know, generally, our data is moving into these cloud platforms being built out by IBM, Microsoft, Amazon, and more specialist companies like OSIsoft, PTC, and what have you. So in that sense, other than the SaaS piece, nothing really changes. But when we start looking at that core network piece, we start to see a lot of new companies. We all know that Ericsson makes core networks and it makes base stations. Same with Nokia, same with Huawei. But we start to see a lot of different providers now. We start to see companies like Druid Software, who won a contract over here in the US for private industrial connectivity for a large company. We start to see companies like Quartus in the UK, who are now doing private industrial LTE core networks for mines and other heavy industries. And we start to see companies like Athernet, who won 5 of the 20 GLOMA awards at Mobile World Congress earlier on this year. That's the equivalent of a telco company picking up all the Oscars. I mean, they got 5 GLOMAS awards. And so the reason that they got those awards is because, a little bit different from, say, Ericsson and Nokia, they're creating core networks that are not designed for telcos to attach tens or hundreds of millions of connections onto. They're selling that core network to companies like MultiTech to be able to deploy in a building and connect thousands, maybe tens of thousands of assets, and connect all our phones so that our extension is our phone and we just walk around the building always connected to each other. So we're working with a number of these companies because certainly in the early days, these are the guys that are putting in all the infrastructure in. The infrastructure is going into those trials and those early proof of concepts. And of course, we want to be connected and attached into that business. Service provider space is also gathering momentum as well. So, maybe if you're an oil and gas or a utility company, you've perhaps got 30 or 40 years of experience managing those 20 different networks that I talked about. So you're probably able to go off and manage your own private LTE network. But a smaller company like us, maybe we don't have all the skill sets to manage a telco network in a building like this. So there's an emerging number of connectivity providers. Some of them you might recognize, American Tower, Crown Castle. They have all the locations around the country where all the cell sites are on. They don't want to compete head-on, of course, with the MNOs, but in this adjacent market of enterprise connectivity, well, they've got all the sites to provide that kind of connectivity. OnGo is a company that does a lot of Wi-Fi connectivity in airports and what have you. Well, Cellular does a lot more than Wi-Fi, and in all fairness, it's a lot better than Wi-Fi. You get a great service all the way until you hit the very edge of the network. And so, of course, they dimension these airports like Dallas Love Field in order to be connected everywhere with a level of capacity that can connect everybody who walks into those buildings and all of the equipment around. So it becomes a much more reliable and mission-critical way to deploy that kind of connectivity. And there's a lot of new guys coming in like Wave Wireless and Geoverse. They kind of are a hybrid. They have their own multi-tenant network. It could have base stations all over the country connecting you, me, and everyone else. But instead of competing with AT&T and Verizon, instead, they just deploy base stations into facilities like the Viking stadiums, like MultiTech, like a fixed wireless access company, and they empower them to go off and create that network without that company having to own the responsibility of managing the core network. And then, of course, there's a whole association for these wireless internet service providers. And so this is an area which we're looking at. So stand up and take a bow, Kevin. A nice little image of you there, holding all your equipment. So for those of you who didn't realize, we set up a private LTE lab. We even press released it, right? We put small cells in there from some of the manufacturers that you saw on those slides. And we've been monkeying around with products and sort of pulling something together that we can sample, which I'll show you in a second. And we've really, at this point, succeeded in our phase one. Our phase one was to get interoperability, which Kevin was able to do across a couple of different cards and core networks and small cells. And so we were able then to decide who we were going to source CBRS modules from so that we could build up products. And we were able to engage with that ecosystem and start saying to them, look, we can provide you samples in May for your network. So that bit, it's a success. We ticked it off. The phase 2 now is all the demos and the trials, which of course we can't do until we get the samples, which as you'll see come next month. And at that point, we start using that private LTE network as a sales tool to show people what we've been doing, how our products connect, the partners that we've connected to. We'll be doing a lot of demos at Mobile World Congress Americas. I'm at a show with a few of the other guys here in Orlando, ConnectX, next month. So that'll be another place where we're promoting what we're doing. And it's not all about CBRS, although I talked a lot about CBRS because it's a real game changer, a USA first. There are other private LTE networks out there like PDV, which is addressing utilities with a 3 meg of spectrum that they own and are trying to get realigned with the FCC. And even AT&T is looking to do a private utility network. And a big thanks to everybody who made our private lab, our facility here, STA approved. That's really important, right? People know where to look to see what's STA approved. They can see when they see our press release and then they look, they can see that we really must have a private LTE lab because we're STA approved. And that means that Kevin and others can test CBRS devices across the air, and we're not upsetting anybody, where we're not breaking the law. We're using the spectrum as a test mode. So it's a special temporary authority, and so who got us our STA, Kevin? You asked some of the guys in QA, right? Right. Well, thank you very much, guys, because that is a big move, getting an STA license. That really helps us in what we're doing, both commercially and technically. Right, so this was an application that we've been working on at Ameren. It's sort of stalled a little bit at the moment, but I guess it's coming back again in the next few days. So this is these big old bins that you see, you know, in the image behind on the top of those masts that we see, and those poles that we see out in the streets. They look like a big sort of cylindrical object. Generally, they're capacitors, and it's all about bringing the power and the phase back in alignment after being in a building like this, where we use a lot of machines, and the machines cause a lot of inductance, and that pushes the phase and the voltage out. So you see these capacitor things all over the place in order to bring the power factor correction in. In many countries, they tend to be underneath the ground. In the US, they're quite visual. You can see them everywhere. So we did a demo where we connected an RCell 100 series, the MNG2 that we've begun sampling, in narrowband IoT mode, and we connected it to an S&C IntelliCap 2000, which is a big selling piece of equipment in this field. And we were able to control that for Ameren using a PDV wireless spectrum and network that is utilizing a Nokia core. So that's a great example of private enterprise LTE. This is something that we're cooking up at the moment with Ericsson. They have a customer in Gothenburg in Sweden who has a manufacturing facility. It has Bluetooth anchors around. You can imagine them in this building at the corners of the rooms. And it enables you to very accurately track where tools and assets might be to within the accuracy of a tile above my head here. And so we put together our eCell with a PoE injector, and that will go directly into the Bluetooth anchor and pull through into an Ericsson network. To give you an idea of the devices on the market today, I pulled this on Thursday. This is the FCC database for CBRS devices in America. And as you can see, there aren't too many of them. There's a Sierra Wireless M.2 cards. In fact, there's a couple of those. There's 3 different SKUs of a Telit Mini PCI Express card. There's a Google Pixel and a Samsung Galaxy S10 an LG 4G phone, and there's a brand new Motorola 5G phone that's just been launched by Verizon in Minneapolis, for example, for the 5G network that just got launched here 2 weeks ago. There are only two devices that are not really consumer per se. One is a Zebra device. They do a lot of barcode readers and NFCs on the roof of commercial and retail buildings. And then Hewlett-Packard relicensed or got a new ID on the same Sierra card. So I guess they can use it in a number of their industrially hardened laptops and what have you. And of course, there's an FCC entry, a test entry. So that is everything that you see in that list. Wouldn't that be great if MultiTech was in that list? And then we would be the first industrial IoT device to ever be CBRS or FCC Part 96 approved. So let's have a little look at how we're going to see if we can do that. So here's a couple of devices that we're going to be sampling next month. In order to do this quickly with a minimum amount of impact, with a network that hasn't yet quite been signed off by the FCC, we outsourced Amit to provide us the eCell, and we just put in there a Sierra wireless card and did some software to bring that up. And then we took the MTR5 and we sort of moved to a more utility oil and gas looking version of that product now, where all of the connections are on the front. It's very utilitarian. You just plug it into a dim mount backplane, and so that's the RCell 600 series. Obviously, the eCell connects anything that's got Ethernet and is running a firewall and a NAT. It can plug into the eCell and it gets a band 48 or 42 or 43 connection. So stick a SIM card in, SIM card attaches to the network, and whatever's coming in and out of that Ethernet is coming out of the device. So pure connectivity story, which is perfect for where the market is right now. Of course, the industrial guys, they want to have more firewall, more VPN software. They probably have machines that don't talk Ethernet all the time. They use Modbus and what have you. So a little bit more complicated for industry. So it's the eCell that we have today, but it's got bands 42, 43, and 48 in it. And it looks like we'll be able to build those up for next month. We did 50 samples of that eCell. We've done 20 samples of this RCell 600, which I'm guessing is perhaps later next month, early June, because we put the priority on the eCell. And this is two demos that we're looking to do over the summer and as we go into the autumn. So we can connect anything Ethernet over the eCell, but what better than an Access AI camera? They have a huge market share in video surveillance. It's pixels with processing power, so they have a huge number of ecosystem app developers who write software, goes in the camera, it can recognize faces, animals, vehicles, density, throughput of people in a busy place, whatever the app is developed to do. But the great thing about this is that you visually see the network, you see pixelation, you see latency. It's a great way to show a network working. And at the moment, Citizen Broadband Radio System is not designed for little sensors. It's designed a little bit like 3G, 4G, 5G. It's designed for broadband, lower latency type applications. In time, it will do Cat-M and narrowband, but right now the focus is on connecting higher value assets, perhaps. And so we can connect our conduit LoRaWAN gateway through a eCell, and we can be able to connect not just the small sensors, but everything up to a high-end video camera and be able to demo that. Although we have no sampling plans today on these products right now, in part because we need a surface mount module that we can put in these products, you can imagine over the summer or into the second half of the year, as those modules start to become available from some of the vendors that we're working with, that we might start picking off some of these products as and when that commercial demand comes at us. And so Who likes Daytona Racetrack? Who would like to go to Daytona Racetrack and not just be one of the people in the stands who is trying to make his phone work, can't get a decent signal, can't boast about being there, can't send all the pictures up to Facebook and what have you? Do you want to be that guy? Well, Nascar doesn't want you to be that guy either. So we provided a number of samples to one of our partners who is connecting up all of the Nascar racetracks across the country, starting with Daytona. And it's kind of smart, actually. What they're doing is that they're doing the smartphone offloading. So you're going to get great, cool quality. You're going to get oodles of data so you can upload your pictures and boast to everybody about how great the day's been. And they'll make money out of that, right? Which helps, with their return on investment. But they can also start doing fan engagement. So turns out, this is a great example of you always learn too much in IoT than you really wanted to know, right? But it turns out that NASCAR fans tend to be a bit older. When they were younger, they were tinkering with the car, making it go fast, putting nitro on there, whatever they were doing, and they were racing their cars. Well, hands up, who fixes their car today? I mean, yeah, exactly. Hardly anyone, right? Because I wouldn't know where to go. I need to get a PC before I can begin, right? Because everything's electronic. So NASCAR is kind of losing that engagement from younger audiences because they didn't have all of that tinkering with their cars. But how cool could it be if you went to Daytona and you could put on AR and VR headsets and you could be inside the car with the driver, looking at him and looking out onto the racetrack and racing around with him, literally augmented reality. And that's the kind of things that they're looking to do at these racetracks. And that's going to cost a lot of money if they're going to be paying that out to commercial networks. I mean, this isn't just a trickle of LoRaWAN data, right? This is massive amounts of data. They want all of that inside the racetrack. They want that high availability, and they don't want to have to be paying per month for every headset and VR headset going on. And then, of course, once you've put a network out there that you're making money on and you're differentiating your service to your customers, well, now you can connect everything. So all the security cameras, the concession stands, the PoE terminals are all connected maybe through an eCell back into the network. And you're not paying monthly fees for any of that connected stuff out there. So thanks ever so much, guys. That's the presentation.